All right, guys. Final exam study guide for 1700. I don't know if I'm going to get through this. As I look through here, there's seven, I think seven, maybe not seven, six, yeah, 7 pages of questions. There are 20 questions. I'm not for sure if I'll get through this in one video or not. We'll just see how it goes and go from there. But I know that most of you like to have the handouts uploaded to Blackboard. It makes total sense to me, but it's going to be hard to do that here because I created this in what's called test gen software. And anyway, long story short, when I export this into Microsoft Word, it doesn't do well. So, do some creative stuff, take screenshots. If you have to, just pause the video and just write it down. I guess it's just the best way to say it. So the first one says, assume that the price per unit D of a certain item to a consumer is given by the equation D equal 35 minus 0.1 X, where X is the number of units in demand. You can see that we have the supply. Find the equilibrium point and the equilibrium quantity. Well, what we want here, guys, is we want to know where, so for number one, we want to know where S is equal to D. So essentially what we can do is we can set, since D is equal to S, we can call this whatever. Let's just call it, for the sake of it, let's just call it Y. So we know that the first demand equation can be rewritten as 35 minus 0.10x. And we know that the second one, since again, because of the unique goal of the problem, finding the equilibrium point, price and quantity, where supply is equal to demand, again, we've got kind of a unique situation here. So we have 0.2x plus 20. Now, I hope you know by now that if you're trying to solve something simultaneously, we have to get our x's and y's together on the same side and get our constants on the other side, on the opposite side. So I'm going to bring that negative 0.10x over here. And I'll see that for my first equality, I have this. And the next thing I want to do is I want to bring this 0.2x over here. And I see I get this. Now, what we should know from now is that we can put this in using augmented matrices. Wow, it's hard for me to do and talk, which usually it isn't. So let's go to the calculator. And it's been a while since we've done this, but it's not that big of a deal. It's easy for me to say, right? So we want a 2 by 3. And I just want to put the numbers into corresponding places. All right, so go second function quit, go back into matrix, go over to math. We need to find RREF, which is at the B for me. Probably is for you too. Go back in and get our matrix A. Close it up. And we'll see that we get 50 and 30. Now, the X is equal to 50 and my Y is equal to 30. So we have to spend a little bit of time and figure out what that means. Well, when we look back up into our problem, we can see that X is the number of units of demand and X is the number of units of supplied. So X is really just our quantity, where Y turns out to be our equilibrium price. So x is the number of units. Yeah, so x is units and x is units. So x is going to be 50 units, so we know that our answer is going to be one of those three. And then y is the equilibrium price, so we know that the answer to this has to be B. So this is going to be kind of cool because we're going to go through a little bit of not only how to do the problems, but we're going to go through some test-taking strategies as well. All right. I can see right now this is going to take a long time, so it's probably going to be broken up into 2 videos, which is fine. Number 2, a piece of equipment was purchased by a company for $10,000 and is assumed to have salvage value of $3,000 in 10 years. So at any time t, we want to find v equals mt plus b. So what I'm going to do here for number 2 is I'm going to set up and I'm going to say, well, when t is equal to 0, when the piece of equipment was purchased, its value was $10,000. And we know 10 years later that its value was $3,000. So since we know that this is a linearly depreciating relationship, we can use our calculator, like I've tried to teach you previously, to work this problem. Now, the way that I've shown you to work this is to go into Stat and clear out the list. So go up and highlight L1, just go clear enter. And we need to come over and get rid of the stuff in L2 as well. Now we know our x's or our times need to go in the first column, and then our value. So when we have 0, we had $10,000 of value, and 10 years later we had $3,000 of value. Now, as I showed you earlier, we can go stat calc linear regression ax plus b. And we have L1, L2. Calculate. And we'll see that our A is negative 700 and our B is 10,000. So if our A is negative 700 and our B is 10,000, then we know this is our answer. So we look up here and we try to find where our value and everything matches up. So guys, it looks like to me that the correct answer is equal to D. All right, number 3. A strain of E. coli something. I'm not even going to try to go there. Theory states in a petri dish will grow, yada, yada, yada. Okay, all that stuff. We got some data points here. And we get down to here and we say, find the exponential equation in y equals a times bx. Now, you're probably, and it says round to 4 places, you're probably going to have to look back in your notes on this. But anyway, what I'm going to do is I'm going to choose 2 points out of this. And I am going to do what Darbo taught me. Okay, that's what I would be thinking. Now we want to achieve a form y equals a times bx. So I have, first of all, I have 2.5, 0.18, and I have 3.5, 0.26. Now I know that this is going to be 0.18 equals a times b raised to the 2.5 power. And I know this is going to be 0.26 equals a times b raised to the 3.5 power. Now, when I was teaching this, I said always put the biggest numbers on top. So I'm going to have 0.26 equals a times b raised to the 3.5 power, and 0.18 equals a times b raised to the 2.5 power. Now, if I take this and divide out, I can see that my a's will cancel. Remember, this is b to the 3.5 over b to the 2.5. This just gives me b to the first power. So this is 0.26 over 0.18. So I'm going to use my calculator to come up with that. So 0.26 divided by 0.18, I get 1.4444 because my instructions say go to 4 places. Now I'm going to tell you, I'm going to cheat here. I'm going to go see if there's any answer that has 1.44 as the and you know what? This is a horrible problem. Absolutely horrible problem, because this requires a regression technique, and I see that now. It turns out that these points don't fall exactly on the line. See, what happens here is we have this exponential function kind of like this. Well, these points are kind of like that, and we're trying to find the line that best fits these points. So that was a poorly selected problem. So let's just go ahead and say that these were the only 2 points that you had just for an academic exercise. And we're trying to fit through these 2 points. We're trying to fit this y equals a times b raised to the x power. So here's where I am right now. So I know that I can put this back in one of these relationships, and I'm just going to use the first one. And put the b equal 1.444 in and raise it to the 2.5 power. Now I need to solve for a. Well, that's going to be really easy to do, because I just need to take 0.18 divided by 1.4444 raised to the 2.5 power. So my a is 0.0718. So guys, putting these two things together, what I could determine is that I have y equal 0.0718 times 1.444 raised to the x power. Now, is that plausible? Well, let's see what we get. If I come over here and graph that, so I'm going to graph 0.0718, 1.444, what, 4 fours? And raise that to the x power. Now I want to come in and choose my window, and I see that my x's a while ago ranged from 2.5 to 3.5. So I'm just going to go from, say, 0 to 5, x scale 1. And I noticed that my y's went from 0.18 to 0.26, so I'm just going to go from 0 to 1. That should give me a decent look at my graph. And albeit very slow, seems reasonable. Now what I want to do is I want to come in and see if my answers are reasonable with this function. So if I go to value, when x was 2.5, if this is the correct answer, I should get something close to 0.18. I feel pretty good about that. When I come up here and go value again and put in x equal 3.5, I should get something pretty close to 0.26. I'm happy. I'm happy with that. So gang, based on the kind of a slick modification of the problem, I would feel very, very good with the answer that I presented right here. Okay, hopefully I don't choose any silly questions anymore. Hopefully. All right, let's go to number 4. Guys, these are ones that when you get stuff like this, you should really kind of lick your chops and be happy and think Darbo loves me. He chose me. It chose a really easy problem. In order to purchase a home, a family borrows $267,000 at 10.8 for 15 years. What is their monthly payment? Round to the nearest, round the answer to the nearest cent. I will bet that most of you, when you started this class, you couldn't have done this. You couldn't have calculated a payment. I'm betting that each and every one of you now can calculate a payment. So, guys, it's easy. Apps, finance, TVM solver. So they are wanting a 15-year. They're wanting to make monthly payments. They have an interest rate of 10.8, so that means their credit must be horrible. Present value is $267,000. My payment, I'm going to put a placeholder there of 0. I want to pay off my loan, so future value is 0, making monthly payments. And guys, make sure down at the bottom you've got this set to end. Come back up to payment, hit green solve. We'll see it's $3,001 and 27 cents. So $3,001. We can easily see this is the answer. Isn't it cool? And the answer that you get is there. Doesn't always work that way, does it? All right, find the compound amount for the deposit, round to the nearest cent. So it looks like what we got here is we got $1,100 at 3% compounded quarterly for 2 years. So how much are we going to have? Well, guys, again, TVM Solver is the tool for you. So let's just go up to the top and change everything. So we have compounded quarterly for 2 years. We have an interest rate of 3%. We start out with $1,100. We didn't add anything else to it. We want to calculate our future value, but our PYCY has to be 4. Future value, therefore, is 1167.76. So 1167.76 would be A. I hope this helps. I really need to be mowing my yard right now, but this is more important. All right. Let's see what. The sun is starting to come in. Let me move over a little bit. Get out of that. All right. So here we go again. Provide use the augmented matrix to solve the system 0.4x1 plus 0.9x2. I'm going to write this bigger so there's no questions. So guys, for number 6, what we're doing here is 0.4x1 plus 0.9x2 equals negative 4.9. And then we have x1 minus 0.3x2 equals 0.5. Guys, I'm going to use augmented matrices to solve this. And I hope at this stage of the game that's what you would think as well. So I'm going to go over to edit, 2 by 3. So just put in the corresponding parts, 0.4, 0.9, negative 4.9, 1, negative 0.3, and 0.5. All right, I'm going to go second function quit. I know sometime recently, so I'm going to go second function entry. I have done one of these. There it is. So gang, I know here that my answer is -1, -5. So -1, -5 would be this. So the correct answer would be A. All right, the next one. A company produces 3 models of MP3 players. Now, I can just kind of look at this and look at the answers, and I can see that this is a system of equations. So when I taught you systems of equations, I said once we see it's one of those types of problems, we need to go to the end of the sentence and ask what is being, or determine what is being asked, determine what they're asking us to solve. And we can see here that it's for each model. Now, we go back up into the problem here, and we see that we have 3 models of MP3 players, Model A, Model B, and Model C. So I know right off the bat that I'm going to let X be the number of Model A's, Y is the number of Model B's, and Z is the number of Model C's. Now I've got to go into the problem, and I've got to put things together, and I see that each one requires electronics, assembly, and quality. So I'm going to have one equation for electronics. And I'm going to circle this because it's going to make it easier for me, okay? So each Model A machine requires 3.2. Each of the B's requires 5.4. And each C requires 2.2 of electronics. The total of electronics that I have due is 303. Next thing I'm going to do is I'm going to focus on the second thing that I've got, and that's assembly. I have 2.8 assembly from A. I have 2.4 assembly from B. And I have 5.8 assembly from C. I have a total of 393 assembly. The next thing I see is I've got some quality assurance. The quality assurance for A is 4.4. The quality assurance for B is 3.4. And the quality assurance for C is 4.8. The total quality assurance that I have is 416. Now I got to put this in my calculator. This is going to be a little bit more involved, but you know, it's still doable. So I'm going to go to Matrix, go over to Edit. Because I need a 3x4 this time, so I'm going to have a lot more typing to do. So I need 3.2, 5.4, 2.2, and 303. I have 2.8, 2.4, 5.8, and 393. And finally 4.4, 3.4, 4.8, and all the quality assurance adds up to 416. All right, Second function, quit. I'm just going to pull that down from above because I'm using the same matrix A. And I can see that I get 30, 20, and 45. So I go to my answer and I try to find the answer, 30, 20, and 45. And I can see that I get that right there. So the correct answer must be B. All right, number 8. A company that manufactures laser printers for computers has a monthly fixed cost of $177,000 and variable cost of $650 per unit. The company sells the printers for $12.50 per unit. How many printers must be sold each month to break even? Well, guys, from this, I see right off the bat that we can use C of X. Our cost is $177,000 plus $650 per unit. And I can see that my revenue is $12.50 each. I know break even occurs when my revenue is equal to my cost. So I have that. I'm going to subtract 650 from both sides. Well, subtract 650x, obviously. So over here I get 600x equals 177,000. Divide by 600. X is going to be $295. So this is not multiple choice. So that's what we get. All right, guys, I'm going to have to move around. The sun is coming in. I always teach here on the back, my sun-in porch here, and it's starting to come in, so I'm going to move around a little bit. Well, it's actually a better view anyway. I don't know what I was thinking about. All right, let's do it. I think what I'm going to do is I'm going to work the first 10 problems, and I'm going to call it a video, and then we'll work the next 10 on the video after that. Okay, so number 9, round to the nearest cent as needed. So the monthly payments on a $73,000 loan at 13% annual interest are $807.38. How much of the first monthly payment will go toward principal? Well, the easiest way to do that is find out what part of it is interest. So we know that interest on the first month on $73,000 at 0.13 over the first month can easily be found. Okay? So the interest is $790.83. So of that $807.38, part of it's going to go to interest And part of it is going to go to reduce principal. I'm over there writing, and you guys can't even see what I'm doing. That's pretty silly. Well, I know that my interest is $790.83. So the difference between this and what goes to interest has to be the amount that goes to principal. Wait a minute. Okay. I don't know what's going on here. We have 807.38 minus 790.83. I get 1655. Well, I guess I do know what's going on. That's it right there. I don't know why, but when I looked down there, I didn't see an answer at 1655, but it's clearly there. All right, number 10, world-class O-ring wants to maximize some profit. So guys, when you see maximize right there, what should you think? The type of problem that makes every single 1700 student cringe. Linear programming. Guys, I know no 1700 level student seems to like it, but we're going to have some. So let's see if we can figure this stuff out. Okay, still not too late to learn it. The first thing we have in a linear programming problem is the objective function. So we are trying to maximize profit, and we have a brass ring and a gold ring. So the first thing I'm going to do is I'm going to establish my variables. I'm going to let X be the number of brass rings, and I'm going to let Y be the number of gold rings. I make a profit, well, they make a profit of $40 on each brass and $30 on each gold. So guys, there is the nuts and bolts of my problem. I'm trying to find the value that will maximize that. Next thing I got to do is I got to come in and get my constraints subject to. Now, I can see that they can produce up to 24 rings each day using the 60 total man-hours of labor. It takes 3 man-hour laborers to, so they can produce up to 24 rings per day. So that's one clear constraint. And then we've got constraints on the man hours. Using up to 60 total man hours. Takes 3 man hours to make the brass. And it takes 2 man hours to make the gold. Now I know that I'm making rings, rings, so I know that my rings have to be greater than or equal to 0. So, guys, way back when, how did we solve these things? We got to get our feasible region, and the first thing we need to do is we need to look at our intercepts. All right, so for the first inequality, I can find my x-intercept by covering up my y. I can find my y-intercept by covering up my x. That was easy. My second inequality, that looks like an exclamation mark, I don't want that. Second inequality, I can cover up the y. So I can divide by 3, I see I get 20. And I can look at the y, cover up the x, I see I get 30. So I'm thinking that what I need to graph on the x's goes out somewhere around 24. And on my y's, I want to go up to around 30. So I'm going to get something going on kind of like that where my feasible region is. Well, let's go ahead and work some things out. So now I see that I want to solve for the first one, so I'm going to have, this is going to be very easy to solve for. And I see that this one is going to end up as 2y less than or equal to negative 3x plus 60, which will end up dividing everything through by 2. So this is a focus, and that's a focus. Now I'm going to use the calculator from here on because I just think that's the easiest way to do this. So I'm going to go into y equal, and I'm going to clear this out. And I'm going to put negative x plus 24. I'll come back and get the inequality later. And I'm going to put, remember if we have fractions, we put those in parentheses. Now, I'm going to go over and set the inequalities. Both of them are less than or equal to, so we'll take care of that as we've done before. Now we've got to get our window looking right. So I said before, when I looked at my graph, I wanted my x's to run out to about 24. No need to look at negative numbers. And I wanted my y's to run to about 30. Now I've got the window set up correctly to get a picture that helps me work the problem. So I can hit graph, and I can see that I get my feasible region. So my feasible region ends up looking like I forgot what it did look like. Guys, the solution has to be one of those 4 points. Now I can use a little bit of common sense here and go back to my intercepts. And I can see that this y-intercept has to be my lowest number because this line, if I extend it up, it would be the highest y-intercept. So I know this value has to be 0 of my y-intercept's 24. I know if I extend this line on over that my x-intercept, this is going to be the biggest one, I need the smallest one, 20, 0. And I know I use my, well, I know this one's going to be 0, 0. And I know that I have to use my calculator to find that one. It's going to be easy to find. Second function, calc, go to intersect number 5, and go enter, enter, enter. When it tells me intersection, that means I've got the points of the intersection, which is 12, 12. Now, gang, the next thing I do is I'm going to come in and look at my objective function. For each of these points, 0, 24, 12, 12, 20, 0. So the first one, 24 times 30 is 720. 12 times 40 plus 12 times 30 is 840. And I can do the 40 times 20 is 860. So the maximum revenue I get is when they make 12 brass watches, or I'm sorry, 12 brass rings and 12 gold rings. So let's find that. That looks like to me that this is D. So we've got that. All right, gang, I'm going to call this video over, and we'll do problems 11 through 20 in the next video.